right, here we go. We're going to do a definition of absolute value, which we did one graphically, but we're going to move on from two variables, right? We had x and y last class. Today we're just going to deal with x, so absolute value is described as distance from 0. Okay? Well, the distance from, we'll say 0. We'll do an example. Okay, so absolute value of x. Okay, and I'm just going to put a number line over here. And I'm going to mark 0, right? Okay. We're going to start shading number lines or putting solutions on a number line. Okay, so absolute value is the distance from 0. So if I say the absolute value of x is equal to 3, this translates as, okay, the x values whose distance from 0 is 3. Okay, where do those dots go on the number line? Which x values have a distance from 0 that's 3? Negative 3 and positive 3. Okay, so notice that there are two solutions. There's not one solution, there are two solutions, because both of these, even though one of them is a negative direction on the number line and the other is a positive direction, the distance, it's like a magnitude, it's positive. Distance is always positive. Okay, so we're going to say distance is always positive. Makes sense? Right? Think of reasonable domains. All right. We're going to start actually with translating some sentences and looking at the simple graphs, and then we'll get into the solving. Okay, so the first part. Absolute value equation graphs. Example 1. Okay. The x values whose distance from 2 is 3. Put it on a number line. Okay. Number line. Notice that I'm asking about distance, which implies that there are going to be two possibilities. Positive distance and the negative direction. X values whose distance from 2 is 3. I'm only going to label the parts that I need. Distance from 2 is 3. What are the other two numbers that go on this number line? True? 5. That would be the positive distance. Okay? That's a, right? Plus 3. and negative 1. That would be the minus 3. Okay, so the solution, what are the x values whose distance from 2 is 3? X equals negative 1 and x equals 5. There are two solutions to this. Notice the symmetry. Absolute value is symmetric. Not always around the origin. It can move around. Okay. So next, we're actually going to do absolute value equations. Absolute value equations. Not just the graph. Right? We have a picture of the graph up here. Okay, keep in mind that we've got a positive direction and a negative direction, but they're both describing the distance. Okay, first example, absolute value of x minus 2 equals 3. Solve for x, right? Solve for x. Now you might be able to just plug in some numbers and give me an answer. But that's not the point. What we need to do is figure out how to set this up so that I can solve it.
You get rid of the absolute value bars and then write two equations down. So one would be x minus 2 equals negative 3 and the other one would be x minus 2 equals 3.
Yeah, okay. Absolute value bars are distance. Distance. Okay? The distance is 3. But really, I have a positive 3 distance and a negative 3 direction. And so this is going to split into two equations. Split into two equations. One for the positive direction on the number line. Positive direction. One for the negative direction. Look at that number line up there. I had to add 3 to 2 and I had to minus 3 from 2 in order to get the 2 points that were solutions because the distance was 3. Distance has no direction, okay? So I have to consider both positive and negative. So you split this into two equations. I like to draw an upside down V because it makes me think of absolute value. And I'm going to split this into two columns. Okay, 1 for, I like putting negative on the left because negative makes me think to the left. Negative direction. X minus 2 equals negative 3. Yeah, it's super simple, guys. I'm not focusing on the algebra. I'm focusing on the setup. 1 for the positive direction. Solve for x. Please don't actually show me adding 2 to both sides. All right, just do that in your head. X equals negative 1. Okay. Notice that the part changing here is the other side of the equals. This is the algebraic interpretation of the question we did above. How do you represent your solutions? Well, we have a few different ways. You can put it on a number line. When you do a number line, guys, just label me the stuff that you need me to see. Don't put tick marks. Don't make it to scale. Just put on the stuff that I need to see. I have a solution dot at negative 1 and a solution dot at 5. I can, however, put a label to my number line. These are X numbers that I'm describing. We also have other ways to describe values. Set notation, because it's not a continuous answer. It's just 2 points. Okay. I want you to just mark the center here. What's the center of negative 1 and 5? Do Do you see the 2 in the equation? X minus 2. Well, it's shifted right 2 from 0 on the number line. And then the distance is 3. Okay, right. There's not a lot of numbers here. You've got A, H, K. You have that B value that I'm not going to ask you to graph. I could put B values in regular equations, okay? So let's set up another one. I'm going to add a couple extra coefficients, all right? Let's do a -2 out here. Let's put a 3x plus 6 on the inside. See how my absolute value bars are taller, so they don't look like a 213 plus 61, right? Make it clear where your absolute value is. Let's do a +1 equals -3. Okay. It splits into 2 equations. But which portion represents distance? That portion. This is the portion that represents distance. That is the only part that has a positive and a negative that goes with it, not this other stuff. And so if you are solving, you have to isolate the distance before you split it up. Isolate the distance before you split it. I want to know what the distance is supposed to be. The trick is you got to do it before you split it. Okay, so this is regular solving. Can I isolate the 3x plus 6 portion? Notice I'm not distributing -2. Absolute value is a little bit more special than parentheses. You cannot actually put this -2 inside. You can't. It doesn't work like that. Absolute value is really a piecewise function. If you want to be able to distribute -2, those need to be parentheses, and they are not. But I don't really want to write this as piecewise. So I'm going to do it a different way. I'm going to isolate my distance. So I'm going to -1. I'm going to divide by -2. And now I'm going to split it. The distance is equal to 2. Okay, so I have the negative direction. Right, think of that number line. I got 2 directions to go. So we're going to go, notice that when I split this up into the direction that I lose the absolute value bars, it's now just regular linear equation. So -2, right? That's for going left on my number line. And then we get 3x plus 6 equals +2 for the positive direction. Okay, solve for x. Okay, I'm just going to leave it there. Right, we can graph them, we can write them in set, you can just box your answer, depends upon what it's asking for. Now, should you be able to plug this back in and check it? You should. However, look at this line here. The distance is 2. Does that sentence make sense? The distance can be 2. Can distance be 2? Yes. Okay. Distance is always positive. Okay, so that step right here, right before I split it, it needs to make sense. Okay, so let's do another question. And we'll look at where maybe we run into some issues. Four minus 1/3 x minus 2 equals 5. Okay. Absolute value. Distance. I would like to isolate my distance portion before I figure out what it's supposed to be. Okay, so see that 4 minus 1/3? There's no grouping symbols there. If it helps you, I mean, that's a +4, guys. It's a +4. It's a negative 1/3 times the absolute value. I just put it in a different order. Do you see the transformation on the left side? Yeah, okay. Let's solve. I'm going to isolate my distance. Going to multiply by -3. If it helps, you can say multiply by -3/1. Notice that this is property of equality. We're doing the same thing on both sides. Okie doke. Now, I'm going to look at my statement. Right now that I've isolated my distance, I need to read the sentence to myself. The distance is equal to -3. Does that sentence actually make sense? No. Guess what, guys? Okay, how do you waste time? You solve something that doesn't need to be solved. There is no more. There is no splitting this up and solving. It will not have an answer. It will not have an answer. Okay. You're like, I'm not convinced, Mrs. Teresi. I just don't understand how you can stop there and just not finish solving this. Okay. What if I do it graphically? Okay. What if I do this? I'm going to graph both sides of this equation. You saw a little bit of this in your homework, right? Where you just have two sides of an equals. And I'm going to graph both of them. Now I'm just going to sketch. Sketch. It means label the vertex, kind of put it in the right place. This vertex is right and up. Okay, so 2, 4, and it's opening down. This is a horizontal line up at y equals 5. Do those two things actually cross? No. It means no solution. So I confirmed, right? I started to do it algebraically, and I was like, gosh, I feel like there's no answer because distance can't be negative. And I wasn't sure. So I went back and I sketched the graph. And I was like, oh, there really is no intersection. There really is no solution. Okay, so be careful. Don't solve too much. You will run out of time. Okay, fourth example. Okay. There's more than a number over there. Okay. Sketch a graph, guys. Sketch a picture. Put the vertex in the right place. Sketch a picture. Because you're like, I don't really know what to do with this. Okay. Having a general idea of what the graph looks like gives you an idea of what you might be looking for. Right? That's how I check my work. I think about the graph to make sure I should be solving it. Okay, sketching just means vertex, maybe one other point. Left 4. Okay. One slope. So, right, I do try to draw my absolute values symmetric because they should be. It's not steep, right? It's a one slope. Just about right. Okay. Negative 2x plus 3. Okay, well, I'm pretty certain that that would be at 4, that y-intercept. It's a one slope, up 4 over 4. Okay, this would be here. Okay, try to get the relative steepness correct. Is negative 2 steeper than this negative 1 slope? Yeah, okay, so just try to make it steeper. I see that these two things only cross once. There should probably only be one solution. Okay, so now that we have an idea that we're actually trying to find an answer, let's set it up algebraically. Oh, is my distance isolated? Yes, it is. Okay, so we still have to split it up for the negative direction and the positive direction. And you're like, well, this is weird. I see negative 2x plus 3. I don't even know what kind of distance that is. Well, guess what? The distance changes based on the x-coordinate. Okay? So the negative direction is going to look like this. X plus 4. Negative whatever it is. Negative of whatever that number's gonna be. Think of your piecewise, right? You put that negative in front of the whole parentheses when you split it up. Okay? My positive direction is gonna look like this. Okay, now it's just a linear equation. Start solving. Right, I'm just dotted line down here so I don't mess it up. So I get x equals 7. Okay. I get x equals negative 1/3. But I only see one answer on my graph. I kind of think this is supposed to be the answer. Based on where it appears to be, the x-coordinate right here appears to be minus 1/3 as opposed to 7. But let me check my work. Now, I'm not a big fan of plug and chug, okay? So we're going to plug it in, and then we're going to talk about what you're looking for so that you can do it faster. We're going to go back to the original, and we're going to check it. 7 plus 4. All right, there's my translation. Distance equals negative 11. No. No, it does not. It cannot equal a negative number. Notice it doesn't even matter so much what I get on the left side. It's the other side of the absolute value that's telling me that it's not working. And so we put an X over it, and it has a special name, a false positive, right? You think it's an answer, but it really doesn't work. False positive. It's called extraneous. It's extra answer. It doesn't actually work. Okay? Has a special name when you solve algebraically and you get an extra answer. Extraneous. Okay. Now I check the minus 1/3. You're like, oh, I don't like fractions. It's okay. You can do it. Okay. See how much work I didn't do? Okay, here's my sentence. Distance equal positive. Because I don't really feel like adding 2/3 and 3. But I do know that 2/3 plus 3 is positive. Does that sentence work? Can distance equal a positive number? Yes. Do you see how I'm not really plugging and chugging? I'm really testing like the general reasonableness of my answer, not the actual arithmetic. So, yeah, that means this is the only answer. Could I have done that graphically a lot faster than plug and chug? Yeah, you can. Okay, so there's a lot of different ways to check your work. So the answer, the only answer, x equals this. That's it. This is the only answer. And I can see it right here. Notice that my sketch just gives me an approximate. It doesn't actually tell me what it is.
Is there a way to find an extremes answer without having to problem?
Okay, yeah, so I look at 7 here, and I'm just going to do a little bit of checking. Graphically, they don't appear. So graphically, I can see that 7 is nowhere near an intersection. Okay? Graphing is pretty quick, especially if you're just sketching to see like where the solutions might occur. Okay? So you can find extraneous graphically. It will not be there. I look at 7 and I say, okay, I'm not even going to look at the distance part. I'm just going to look here. -2 times 7, negative. Ooh, negative number on the other side. Not an answer. That's what I would do. This is as much as I would do. I would not actually plug and chug every single step. It is a waste of time if you can determine it earlier. Yeah.
Is there any way to like check? Do you have to check their answer?
No, okay, so the only reason you check your work in Algebra 1 is you're really just seeing if you messed up your arithmetic somewhere, okay? I'm going to assume you're not messing up your arithmetic, okay? You only need to check your answers when there's a potential to have an extraneous solution, okay? How do you know an extraneous solution might occur? Okay, so I look at this. Well, actually, let's go up here. Okay, can distance be negative? No, so I stop. If you had solved this, you would have gotten 2 extraneous solutions because they never would have worked because the other side is negative. So I look here at my question. Notice the distance is isolated. And I'm going to cover it up and I'm going to look at this other side. Can this expression, -2x plus 3, ever be negative? Right? Notice that's a linear equation. The domain is all real numbers. Can you plug in an x where you're going to get a negative answer? Yeah, that means you have to check for extraneous because the other side could possibly be negative. I don't know when, right? It could be negative. I see on my graph that I have negative outcomes. These things can't cross. They have to cross in a positive outcome. Okay? So if the other side f at any point could be negative, you have to check for extraneous. So let's do, if I go back and I look at the previous example, notice that when I have my distance equal to positive, is this side ever going to be negative? No, that's why they both work. That's why I didn't check my work, because I knew it was going to work. Has to, unless you make an addition mistake or a multiplication mistake. Okay, I get here. Distance equal positive. That's reasonable. There is no extraneous answer because distance can be positive too. I go here. Distance cannot be -3. Ooh, no solution. And then I get down here and I'm like, oh, distance can be some number I can't determine. I don't know if this number is positive or negative, therefore you have to check it. Have to. But if you already know plus or minus, there is no checking to be done. This is the uncertainty. Like, I don't know what the other side is. It depends upon what I get for x. All right, guys.